So hello coders, welcome to our channel, Level Up with Coding. Today I will discuss about the today's Leetcode daily challenge question, maximize happiness of selected children. You are given an array happiness of length n and positive integers k. There are n children standing in a queue where the ith children has happiness of I. You want to select k children from this and n children in k returns. Return the maximum sum of happiness value of selected children you can achieve by selecting k children. And note the happiness value cannot become negatives and get the decrement only if it is positive. So input happiness are 1, 2, 3, k equals to 2. So output is false for 4. Explanation is we can pick up two children in the following way. So first time we have to pick up the happiness value is equals to 3 and the happiness value of the remaining children are 0 and 1. So in second time you have pick up the happiness value is 1 and the remaining children have become 0. So 3 plus 1 that is 4. So the output is become 4. And in second time the happiness is 1 1 1 1. So k equals to 2. So the output is 1. And in the third time 2 3 4 5. So k equals to 1. So output is 5. So constants are 1 is less than equals to n equals to the happiness dot length less than equals to 2 into 10 to the power 5. So you have to give the best approach. Okay. Now we discuss about the question.
So the question saying about the maximum happiness of selected children. You are given an array happiness of length n and you have to return the positive integer k. Okay, and you have to return the maximum sum of happiness value of the selected children you can achieve selecting k children. So in first example, happiness are in the array 1, 2 and 3 and k equals to 2. So we can pick two children, okay, because k equals to 2. So we can pick two children in the following way. Pick the children with the happiness value of 3 because we have to pick the maximum one. Okay, so first time we pick the value equals to 3. The happiness value of remaining children's are the happiness value of remaining children's are 0 and 1. Why? Because when you pick the one element or the maximum value, the happiness of other children are decrement by 1. So 1 is decrement by 1, so that's why it's 0, and 2 is decrement by 1, that's why it's 1. So 0 comma 1. So now pick the children with happiness value of 1 because you have to pick the maximum values. Okay, so in 0 and 1 we pick the maximum value, that is 1, and now remaining are 0 because also you have to check, uh, note that the happiness value cannot negative, it's always positive. Okay, 0 or positive, not negative. So you can check there k is equals to 2 and we choose our happiness values, that's are 3 plus 1 equals to 4. So that's why the output is 4 in there. Example 2, you can check 1 1 1 and 1. So k is 2. You can pick two elements, two children. So first time you can check there the elements are same, so we check the value 1 or we pick the value 1. So remaining are 0 0 0 because it's decrement by 1. So in second time we pick the value 0, so and it's decrement, but it's not decrement because if it decrement it's written negative. So k is equals to 2, so we pick up our two elements, that's are 1 and 0, so output is basically 1. So that's how we do the question. It's very easy question and you can check it's a greedy problem because every time we do the maximum value, every time we do maximum value, so you can do it with short greater element or use priority queue. In priority queue you pick the maximum element and then do the code. In priority queue the time complexity is basically O of n log n and the space complexity is O of n. It's optimal code. Now we code it.
So first of all, we initialize a priority queue with long long and then long long total happiness and push all elements of the of happiness into the priority queue. So pq dot push the happiness. Okay, and now long long decrement equals to 0. Iterate the k times. Okay, so because k is initialized with elements and we have to iterate with in the k times. And now long children's happiness equals to pq dot top because in priority queue the most data element you have to choose. So pq dot top, get the top element of the priority queue, then remove the top element and then adjust the happiness by decrement. So children's happiness minus equals to decrement. So first time decrement is equals to 0. So in first time decrement is 0 time and in second time decrement is increment. So d plus plus. So in second time d is equals to 1 and in decrement with by 1. If the adjusted happiness is non-negative, add it to be total happiness. So you have to check it's negative or non-negative because you have to return with the non-negative and then decrement the k. At the end, return the total happiness. So the time complexity in there is O of n log n and the space complexity is O of n. So run. So all accepted, submit. Okay, it's accepted easily. So thank you for watching.